Hello again, this is Borgdude on Clojure, and today I want to show you how to use a pod, a Babashka pod specifically, and what problems it can solve for you. As an example, I will start with a script that I already showed in a previous video in how to use a library from Clojars in Babashka. So let's take this as a starting point. And I'll zoom in a little bit. So what we've done here is we have a script that shells out to SQLite. And so we use the Honey SQL library to produce some SQL queries. And then we shell out to SQLite to execute those queries. And in this script, we shell out a couple of times. The first time is when we create the database. So when we create the database, we execute the query here, and the query is then some create statement, create table with some columns. So that's the first time we shell out, and we don't care about the result. So this is just an action that we do. The second time we shell out to SQLite is here. So insert rows, this will start another SQLite process to insert these rows. And we do that using some SQL that we generate using the Honey SQL library. And then we actually check the results of the process that we shell out to, so the exit code, and if it's not zero, then we throw, or we actually not even throw, but we exit the script with the same exit code. So this is all shelling out code, and the third time we shell out to SQLite is when we do when we do a select statement, and we actually have to parse the output manually because SQLite returns some CSV-like results. So we use the Clojure data CSV library to parse this, and then we can print it. This is all fine. This all works. No problem. But there are some ways to make this even nicer. So I will show that this works. So BB, what's the script called again? SQLite shell Honey SQL. So this is using shelling out with the Honey SQL library. Okay, so this works, and it's pretty fast. So it's 94 milliseconds in total to shell out 3 times to SQLite and to include also the Honey SQL library. So loading the Honey SQL library actually takes 50 milliseconds. I've measured this. So 50 milliseconds to load this library. It's 1400 lines of Clojure code. But then we also shell out 3 times to SQLite, which adds to the total time that we need to execute the script. So this is fine, but a pod can make this even nicer. So what SQLite pod will solve is that we don't have to shell out manually, and that this is my wife Barbara in the background. So we only have to shell out, we don't have to shell out manually. So a pod is started only once in the background, and then it runs kind of a server that we can just keep talking to as long as this script runs. So I will show what that looks like. So I have this script here. So you can see it's also, the script is now also shorter. So, and the number of namespaces that we need in total is also less. So to load a pod, we use the Babashka pods namespace. And then you say, I want to load the pod. And when you use a qualified symbol here, then the pod will be looked up from the pod registry. So you can load a pod from the local file system. You can just download it manually from GitHub releases. And then you can fill in a local path here. But if you use a qualified symbol, then Babashka will go look into the pod registry for this registered pod, and it also needs a version. Okay, so the pod registry, that's Babashka pod registry on GitHub. So we have a list of all kinds of pods that you can use from a Babashka script. And today we are using the org Babashka go-sqlite3 pod, which is written in Go. And it's relatively small pod. So you can see all of the source code here. So it's one Go file. It's only 200 some lines. And it uses the go-sqlite3 library under the hood. And the nice thing about this library is that you don't actually need to install SQLite on your system, because it's all a standalone solution. So pods can be written in Go, but they can also be written in Clojure or Rust or Haskell, as long as they expose the right data using a certain protocol, which we call the pod protocol. And so let's go back to the script. So that is what happens here. So the pod is loaded, which means it started in the background as a kind of a server. If you don't have this pod yet on your system, then Babashka will automatically download it. So it's downloaded to Babashka repository, pods repository, org Babashka, and then go SQLite. So you can see it's here. This is where Babashka has downloaded it. And you can also see the size. It's not, because it's written in Go, it's relatively small and fast. So that's a nice thing about Go. So when we load this pod, we actually pay only the startup time once. And okay, that is happening here. And the pod keeps running until we terminate the script. What this pod also does, it exposes namespaces and vars. I'm looking at the time. Yeah, okay. So the namespaces, this pod only exposes one namespace, which is the go-sqlite namespace. And so we can just require it, but you can only require it after you loaded the pod. Okay, so now we continue with the script as we had it before. So we load HoneySQL as well. But instead of shelling out, we can now directly call SQLite execute, and that will just work because this SQL data here that is serialized to JSON or Transit or Eden and then sent to the server, the pod server process. And what we get back is another JSON, Transit or Eden value, which is deserialized, and that will be the result of this function call. So this is all transparent to you as a pod user, but this is what happens in the background. So so here we have another call. We don't need any shelling out or exit code checking or whatever. And what's nice is that we don't have to parse the output anymore, because the the output is already eaten. It's already just closure values. So we can just pretty print what came back from this query. Instead of what we did here is we had to parse the CSV output from SQLite. So it's a nicer integrated, more integrated experience. So I will show that this script also works. Let's see, honey SQL pod. Okay. Well, it loads the pod once, so that always takes a little bit more time. But you can see it's, yeah, it's more or less just as fast or faster. Let's see. This is the old one. It's 100 milliseconds. And this is using the pod, which is slightly faster, as you can see. Shell pod. Okay, but so there is a benefit of only paying the startup time once, and you get these, yeah, you get just function calls for free, and it uses the deserialization of the values. It does it all for you, and if something bad happens, you will just get an exception instead of that you will have to check the exit codes manually. So that is the main benefit of using a pod, and a pod can be written in any language as long as you expose the right data. I think I will do another video about how to write a pod, but if you're already curious, you can go to the Babashka pods repository, where this is explained pretty extensively. How to write a pod, and there is plenty of examples around that you can look at. So you can write a pod. Anyone can write a pod. It's not a closed system. It's an open system. So it's basically a library that is self-contained into an executable that you can use from Babashka. And if you have written a pod, I would be happy to include it in the pod registry. Okay, so if you like this video, or you're using Babashka on a regular basis and you like this concept, you can go to GitHub. Let's see. You can go to GitHub, and then you can sponsor me there if you want. Feel free to ask any questions about Babashka in the Babashka Slack channel, and maybe see you next time. Leave a comment if you like this video, and leave some feedback. That's always nice for me. See you next time.